Hey everyone, I'm Said and welcome back. In this video, we're gonna study one of the most important ideas in calculus, the definite integral. When we worked with indefinite integrals, our answer was a family of functions and we always added c. But now the situation is different. A definite integral gives us a number, not a family of functions. Suppose we have a function f of x and we want to study it from x is a to x is b. Then we write the integral of f of x dx from a to b. This is called the definite integral from f of x from a to b. So here a is the lower limit and b is the upper limit, f of x is the integrand, and dx tells us the variable of integration. Now conceptually, the definite integral represents the net signed area between the graph of f of x and the x-axis from x is a to b. So look at this graph. In this graph, the integral of f of x from a to b dx is s1 plus negative s2 because area above the x-axis is counted as positive and area below the x-axis is counted as negative. So the integral of f of x from a to b dx is a number, is not a function. This is one of the biggest difference between an indefinite integral and a definite integral. For example, the integral of 2x dx equals x squared plus c. This is an indefinite integral, but the integral of 2x dx from 1 to 3 is a definite integral, so the answer will be just a number, right? So to compute a definite integral, we use the fundamental theorem of calculus. Means if f prime of x is f of x, then the integral of f of x from a to b dx equals f of b minus f of a. This means first find an antiderivative of f of x, then evaluate it at the upper limit, then subtract its value at the lower limit. This process is often written using bracket notation, means the integral of f of x dx from a to b is f of x from a to b, which means f of b minus f of a. For example, the integral of 2x dx from 1 to 3 equals an antiderivative of 2x is x squared, right? So we write x squared from 1 to 3. Now substitute the upper limit first. We have 3 squared, then subtract the value at the lower limit, means minus 1 squared equals 9 minus 1 is 8. So the integral of 2x dx from 1 to 3 is 8. Notice again, no plus c because the result is a number. Now let's try another one. The integral of sine of x dx from 0 to pi equals an antiderivative of sine of x is negative cosine of x from 0 to pi. So we have, if x is pi, so negative cosine of pi is positive 1 minus If x is 0, so negative cosine of 0 is negative 1. So the answer is 2. So the integral of sine of x dx from 0 to pi is 2. Now let's organize the most important properties. Number 1, the integral of f of x dx from a to a is 0. Means if the upper and lower limits are the same, then the integral is 0. But why? Because there is no interval, so there is no accumulated change, right? For example, the integral of sine of x dx from pi to pi is 0, right? Or, for example, the integral of tangent of x dx from pi over 4 to pi over 4 is 0. Or the integral of the square root of x dx from 2 to 2 is 0. Number 2, if we switch the limits of integration, the sign changes. Means the integral of f of x dx from a to b is negative the integral of f of x dx from b to a. So reversing the interval reverses the sign. Number 3, if c is between a and b, then the integral of f of x dx from a to b equals the integral of f of x dx from a to c plus the integral of f of x dx from c to b. For example, the integral of sine of x dx from 0 to 2 pi equals the integral of 0 to pi sine of x dx plus the integral of pi to 2 pi sine of x dx, right? Or, for example, 1 is between 0 and 5, right? So the integral of x dx from 0 to 5 equals the integral of 0 to 1 x dx plus the integral of x dx from 1 to 5. So this means we can break one integral into two similar integrals. This is very useful when the interval changes direction or when the function is easier to analyze in pieces. The integral of k f of x dx from a to b equals k the integral of f of x dx from a to b, where k is a constant, means a constant can be factored out. For example, the integral of k dx from a to b equals k times b minus a. But why? Because the integral of k dx from a to b equals the integral of k dx is kx from a to b, or k times x from a to b, so we have k times b minus a, b minus a. The integral of a sum is the sum of the integrals, means the integral of f of x plus g of x dx from a to b equals the integral of f of x from a to b plus the integral of g of x dx from a to b. And similarly, the integral of f of x minus g of x dx from a to b equals the integral of f of x dx from a to b minus the integral of g of x dx from a to b. The integral of 0 from a to b dx equals 0. If f of x is greater than or equal to g of x for all x is in a to b, so the integral of f of x dx from a to b is greater than or equal to the integral of g of x dx from a to b. And if f of x is non-negative for all x is in a to b, so the integral of f of x dx from a to b is non-negative. And if f of x is between m and m for all x is in a to b, so the integral of f of x dx from a to b is between m times b minus a and m times b minus a. The absolute value of the integral of f of x dx from a to b is less than or equal to the integral of the absolute value of f of x dx from a to b. If f is odd, meaning f of negative x equals negative f of x, so the integral of f of x dx from negative a to a is 0, right? For example, sine of x is odd, so the integral of sine of x dx from negative pi to pi is 0, because the integral of sine of x dx from negative pi to pi equals the integral of sine of x is negative cosine of x from negative pi to pi. So we have negative cosine of pi is negative 1 minus cosine of negative pi is negative 1. So we have negative 0, means 0, right? Or the integral of x dx from negative 1 to 1 equals the integral of x is 1/2 x squared. X squared from negative 1 to 1 equals 1/2 times 1 squared is 1 minus negative 1 squared is 1. So we have 0. And if f is even, meaning f of negative x equals f of x, so the integral of f of x dx from negative a to a is 2 times the integral of f of x dx from 0 to a, right? Meaning, for example, the integral of x squared, because x squared is even, dx from negative 1 to 1 equals, we know that the integral of x squared is 1 over 3 x cubed, right? From negative 1 to 1. So we have 1 over 3 times 1 cubed is 1 minus negative 1 cubed is negative 1. So we have 1 plus 1 is 2 over 3, right? Or according to these properties, we have the integral of x squared dx from negative 1 to 1 equals 2 times the integral of x squared dx from 0 to 1, right? 2 times the integral of x squared is 1 over 3 x cubed, right? From 0 to 1. So 1 cubed is 1 and 0 cubed is 0. So 1 minus 0 is 1. So 2 times 1 over 3 is 2 over 3.